All right, so today we're going to talk about resistors. So these little guys over here, yep, that's them. Okay, so basically what a resistor is, it's something that provides resistance to electricity. Duh, right? So resistance, impedance, whatever you guys want to call it. And so you would measure resistance in the form of ohms, and ohms, it's basically a unit that says how much it can obstruct the flow of electricity. And yeah, so let's see how we can read the value of these resistors today. So I have already written a few values, so let me take one that's not done. Okay, so we normally see four bends like this. Maybe they differ, I'm not sure. But what we do is we read from this point, and normally the end colors would be something like silver or gold. And we match the colors. So let's take an example of this one. What we see is it's brown, black, red, and gold, if I'm not wrong. So let's take a look at that over here. So that was brown. So brown, the first value would be a 1. And the next is black. So black corresponds to 0. So we have a 1, a 0. And the third color here is a red. So red means third value, 10 to the power of 2. Okay. So, and what else do we have? Yeah, we have a gold, and gold means it's a plus or minus 5% tolerance. All right, so as we can see, this is 10 into 10 squared. So that's basically, it's equal to 1,000 ohms. Ignore the way I'm writing really messy. But yeah, that should be right. Okay, let's check out another one over here. This is a little interesting because it has 2 strips of gold over here. So we have brown, black, and 2 golds. So if we look over here, that is 1, 0 into 10 to the power of minus 1 with plus or minus 5% tolerance. So that would make it 1, 0 into 10 to the power of minus 1 plus or minus 5%. So yeah, what do we get here? We basically get 1 ohm. All right, so that's it. And I hope this was helpful. So yeah, thank you. Okay, so it came to my attention that while I did explain what a resistor was, I didn't quite give an intuition as to why we need resistors. So yeah, I'm gonna try to explain that here. Let's consider a power source, maybe a tiny battery over here, and let's consider an analogy. Okay, so electricity is sort of like a dam. Let's say a dam, a very large dam of water. And we know that water in a dam flows very rapidly. There's very heavy flow of water. So let's say this is water gushing. And eventually, where does the water go? It goes to different outlets, right? And maybe in my case, let me consider this a tap in my house, and I want to fill a tiny glass of water. So now what happens if this dam, the same flow of electricity, goes to my tiny tap? So in that case, it would obviously fill my glass of water, but it would also flood my house and the whole locality, which is not something we want. So what do we do in that case? We would create a small pipe, right? So in this case, we're shrinking the channel, and we're obviously applying some kind of resistance. So that's the same case in a resistor. So if we have some power source, a resistor helps sort of regulate and obstruct the flow of electricity, so we get exactly how much we need for whatever outlet we're trying to use it for. And in this case, since we need a lot of resistance, we'd have to go for a large resistor. And let me just take an example here. So this one right here, this little guy is 33 kilo ohms. Okay. And let's take another use case. Probably this would be an analogy of maybe a light bulb. So a light bulb doesn't need a lot of electricity, but it does need some. So we'd use a bigger resistor for that. And let's take another case where I have a different source of outlet. Maybe I want to fill a tank for a locality. So for this, I need water to flow, but I don't want it to flow this much or this little. So obviously that would never fill it up. So I need it somewhere in between. So I need resistance, but not a lot of resistance. So let's say in that case, I would use something like 1 kilo ohm. So yeah, and that's exactly the point. So resistors are used to restrict or resist the flow of electricity so that it suits whatever other component it's connecting to. And I hope this was clear. Also, I used the analogy of water to explain the flow or transport of electricity because water is a good conductor. Okay, so yeah, that is it for today. My daily dosage of teaching as well as dad jokes. So, all right, bye-bye, everybody.